All right, basic descriptive geometry introduction. And this particular one, we're going to do point projection. I'm going to show you how to do the first one, and then you're going to have to do the second one all on your own. So I'm going to show you partial in these videos. So what we're trying to do is we're trying to find our point of projection. So if you look up here in your three-dimensional model at the top, it's showing you that we're finding lines to lines. So what we do is we're going to take and lay out this line as it folds out into all three views, and then we're going to take it and do the same thing, but now we're going to find out what does it look like in 3D inside of that cube of that box. So we're finding a line, we're finding points that are on multiple planes that are at an angle. So it could be slicing through. For an example that I like to explain for this one is you're doing piping. You're running the piping through the concrete of a house, and it has to go at a specific angle. Well, you need to know where is it going in each one of those views, how long it is, etc. Kind of the whole reason why you need to do auxiliary views. So we're just going to practice laying this one. First thing I want to start with is a couple of things that I need to know. I need to remind myself that I get my height here in that frontal plane. I get my width here in the frontal plane, and also in the horizontal plane. You also get your height obviously in the profile plane, and this time the profile is going to the left, and that's okay. Sometimes it's going to happen. And then where do I get my depth? My depth comes there in your horizontal plane, your top view. It's also here in your profile. So you need to remember those things when we start measuring out these points here. And I'm going to draw everything very lightly, not too light so that you can see it at least, but it's got to be light. So we're going to have to do some measurements. I'm going to use my Plano engineering scale 1 to 1. I'm going to start off with my first one. So point A has a height of 0.7. So I'm going to measure down on that height, 0.7. Take my divider, find 0.7 with it on my engineering scale. Transfer that height right here from corner to corner and mark it. Keep your paper tape down. Lightly draw. So there's my first one, point A. All right, the next one has got a depth of 0.18. Again, transfer it and find it on the architect scale. Engineering scale. There it goes. It's going to be depth, so it's going to be going this direction, right? Not that one, my light one. So here, it also goes here because it's depth. So lightly draw there, lightly draw here. Just playing a giant game of connect the dots kind of right now. We've got to find all those little dots. All right, our next one, it's got a width of 0.5. Take those dividers, get that measurement, and transfer it. So remember, width is running this way. Mark it and transfer it. So each of these in this view here, on this line here, on this line here, those are going to give me my A's. Now I need to find my B's. If you have problems with this, this may be one of the few times where you want to get a marker or a colored pencil, etc., to try to help you get out a little bit. What I mean by that is I would take all of my A's and make them one color, just to make it a little easier for me here in a minute when I start to do the next color. So now we're going to find B. B has a height of 1.8. Again, just find it on your engineering scale. And mark it. So 1.8 comes down, way down here. Okay, so we have the height. We need to get our depth. The depth on it is 1.2. Again, measure on all your depths. that's this way. Remember, keep track of that direction. And then the last one is the width, 1.7. There we go. So now we're going to play connect the dots. So we know all the A's are on the yellow and the B's are going to be on, well, the non-colored in this particular case. So I need to find A, B. A will be towards the top, B is going to be towards the back. So A is going to start here, come back. Let me get my thicker lid. There we go. So that point to that point. So this one becomes A, and this point becomes B. Same thing here. A is still here. It's coming down. So where do they meet? Crap. Dang it. I hate it when I do that. That's what happens when your triangle slips. Get A, B. And then over in this view, where does it meet? So here comes A, and A comes down to B. So we found it, we've broken it out over its views. Now we want to actually transfer it and do it three-dimensional like the example given in the model here. So how are we going to do that? Same thing, we know, again, our height, our width, the depth. And we just do the exact same thing again. We're just going to transfer measurement. So we're going to start off with that 0.7. .7 on the height. And if we're lucky, this is a 45. If we're not, or 30/60. If not, then we're going to have to move our paper around. Let's see if we've lucked out. And we have, it's on the 30. So say I can use my triangle. It lines up with that same. So I can draw my height back, all right? Our depth, 0.8. Again, depth. Edge and bring it down here on the edge where it connects, and then 0.5 for the width. And then that same thing, because I know that matches that angle, so I bring that over. So our A is essentially here, here, and here to start off. The problem is we need to find out where does it come, where do those points come to and meet in the 3D world. And again, I am just using color to make it a little easier, hopefully for y'all to see. You do not have to, I'm just trying to help y'all visualize it. So we want to find out where does this A come back and meet on all these points. So to do that, come down at the 90 here, and horizontal here. Yeah, pretty much it, yep. This becomes my point A. Let's find point B. Now let's repeat the process. 1.8 for our height. Again, height. Come on, mark. Get it on the profile also. Let's come down a little bit. There we go. Depth is 1.2. Over, down, so here, and our width is 1.7.
Hey,
Hi.
I'm back.
What, the menstruating? Yeah, I call it menstruating.
All right, and then we're going to find the 1.7 width. Again, following the width. Mark it. And pull it back. And then we want to find where it meets. So we have to kind of find those points because this is now B here, B here, B here. So notice how it matches to the B's like we had it laid out flat. And now let's play connect the B's. Bringing that over. Bringing it down. So now it's going to become that point B. And to get it three-dimensional, you literally play. Let's get my darker lead so it shows up a little better. Here. Come on, get in there. Here it goes. There. So there's your line. There's your point in 3D. In 3D space. There's your A, B in 3D space. And then you repeat the same process to finish doing it for the bottom part here. But I'm not going to do that. You're going to have to do it on your own by looking at the examples. Don't forget to come back over this and fill out the title block, point projection drawing, today's date, and your name. This one's worth 25 points. Use this video to help you with the steps on how to do it, and use the example given to you. The example I'm going to give to you is the AutoCAD version of the file that's color-coded to make it a little easier for you to see than some of these scanned-in examples, because I know they're not the best quality as I would like them to be, so I'm hoping that the AutoCAD is going to help it to be a little better because the lines are clearer and the colors are easier to understand. All right, see you in lab.